Hello everyone. So in this video, we are going to talk about a vulnerability in a third-party library called PDF.js. As the name suggests, it's a JavaScript library and is very famous among developers. It's primarily used to interact with PDFs, used in web applications and desktop applications. So I have been able to find this vulnerability in a lot of applications, and I'll explain the reasoning behind that, as well as why you should be careful if you have some application that interacts with PDFs. Coming to what is this vulnerability and what it does, just like a summary first. So it allows us to execute any JavaScript we want to execute on the client side. So for example, if we want to maybe alert the user for something, we can do that. Maybe if we want to run something, fetch some document cookies, or maybe play with local storage, anything on those lines is possible because we are able to execute anything in JavaScript within the browser or the desktop application we are talking about. So this has the unique ID, CVE ID shows. This is from 2024. Anybody who doesn't know what is CVE is, basically common vulnerability and exposures, basically a list of all the common vulnerabilities publicly disclosed, which are used by people for testing and multiple reasons. Won't get into too many details here. 4367 is the unique identifier for this vulnerability for this in this unique CVE ID. So what version of this library are vulnerable? Prior to 4.2.67, all the packages, like the versions of this library are vulnerable. Again, what is CVSS score? CVSS score is vulnerability scoring. Basically shows how dangerous the vulnerability is. Ranges between 0 to 10. Here 8.8 shows it's a bit dangerous. As we talked about 2024 vulnerability, why are we talking about this in 2026? The gist of it is I was able to find a lot of applications which were vulnerable to this specific exploit we are going to cover here in the video. The reasoning is most of the people are not aware about their code bases, and even if they are using some PDF library, there's also a good chance that it's either directly PDF.js or an indirect library which uses PDF.js internally. So this was an interesting fact. And secondly is most of the vibe coding applications made today, for example, if we use GitHub Copilot to code something, it's trained on public repositories on GitHub. So it's a very good chance that it'll pick something up and randomly give you an older version of the package, which ideally shouldn't happen but could happen. Additionally, you might be thinking, why are we talking about PDF applications specifically, when there won't be a large number of applications using PDFs or interacting with them. But that's not the case. So this article was written in April this year, and the weekly downloads at the time of writing were like 12 million, which is very huge. I checked just right now and shows 14 million, which is just from this single source of npm package manager. However, there are different sources. For example, somebody could download GitHub code itself and compile it because the code is open source. Coming back here, what is the vulnerability? Where does it lie? So if you open any PDF in a text viewer, for example, I've opened a PDF here. Not sure. Yeah. So so the entire PDF is made of certain set of information about the PDF itself. What should be the font size? What should be the color? What should be if there are any annotations, any text, any comments you have made. Everything is stored within the PDF file in a certain format. Okay. The vulnerability specifically lies in the font section, specifically the font matrix part. Font matrix is an array containing 6 elements, and it should ideally be containing numbers, which basically are useful for scaling, transformations, and like it's related to text and the font and how the font is displayed. One of the factors in that. So interestingly, if we pass another string value, this test string acts as a string here. If we pass it here in the font matrix, it ultimately creates the code of something on this line. For example, so we are not going into too much detail of what's exactly done. To summarize, it's basically dynamically generating code at runtime basis what is passed here. So this transform function covers and contains what exactly is passed here as a parameter. And if we use some JavaScript knowledge, what we can do is we can try to escape this, specifically this last case, and try to add some JavaScript here within the font matrix in order to run something on the application, for example. So we have a simple exploit here. We're going to talk about this and how and why it works. So we are just trying to put a 0 at the 6th place. We'll just replace the 6th place with this and then try to explain why it works. We'll just close the font matrix here. Yeah. Okay. So ideally it should have been 6 elements, and we put the 6th element. You can put any number here, doesn't matter. We put the 6th element just to make sure syntax is valid. Then we use an escape character just to make sure that this is not considered as a closing bracket but as data itself. Okay. We want to consider it as data, and the reasoning behind is that we want to make sure this code stays relevant whatever we want to pass here. We put a semicolon here after the bracket. The reason is to basically ensure that these 6 parameters go into the transform function and directly are here. So this will become instead of test string, it will become 0, and this is sorted for now. Once this function is sorted because of this semicolon, we now have the freedom to write whatever code we want to and let that execute. So if we write alert 1 and a semicolon here, it'll alert us with a value of 1, and yeah, that's it. We just put comments, 2 slashes at the end to comment out anything after this, written after this. And the reason is to ensure that there's no syntax mess ups or something on those lines. Now, what is the exploitation? Generally, things are exploitable when those are rendered. PDF.js is used for parsing and rendering those PDFs. So whatever value you pass it in font matrix is going to be converted into a transform function at the runtime, and interestingly, that is going to be executed at runtime in the web application or the desktop application. In this case, this is a college application, like application portal. Basically, they wanted some Aadhaar card or any identity proof showing the identity of the individual who is applying. However, if I upload a proof of concept file here, what happens is that I am able to get the JavaScript execution. The interesting part is that I can change the code however and whatever way I want to. I really can't show a specific application with name, so I found this interesting GitHub repository for showing a demo, and I've just launched it. We are going to go into the Vue.js section, and this is the document which should be rendered perfectly fine. There's no issue with this document. However, when we change it to another document, here we have written gotcha. This is from the repository directly. We'll change it as well. If we try to open the component which is rendering the PDF file and replace it with example 1 here, what we see is an alert box with executing whatever JavaScript was passed to it, and is super interesting. Now going back to the file, I've just created a payload for the origin and the document URL. I'll just replace the alert box here with the same. 1 second. We'll close the font matrix again. Yeah, this looks fine. We save it. If we click OK, refresh, now it shows the origin URL, which is the service, the domain name, along with the port, and we also got the PDF URL, basically the URL where the PDF is shown, which is this same URL. Why is it dangerous? Okay, so what JavaScript execution gives you is the power to basically steal any authentication tokens, cookies which are not marked as HTTP only, or play with local storage, as I talked earlier. What people can do, attackers can do specifically, is they can steal your tokens, which could allow them to replicate the session. What is a session? Basically, when you log in with your ID and password, it gives you a specific set of tokens, or a single token, whatever the case be, and you can just put it in your application and you'll be logged in as the user who was exploited. That is problematic and is a big pain point. The ways to solve this is when this JavaScript conversion happens, that is from font matrix, it gets converted into actual JavaScript within the transform function. What we can do is we can disable is eval supported and set that to false. So basically, whenever you are opening a PDF, there's an option to set is eval supported as false as a key value pair, and you can pass that in. It can basically allow you to disable any runtime code execution and solves the issue. Another way is to strictly validate the font matrix values. Slightly tougher, but very strong resolution to the problem as well. The third one is not very practical these days, because there's a lot of stuff happening and exploits are able to escape sandboxes. However, one of the ways to solve the issue is to render the PDF within a sandbox, so it remains in an isolated environment. So the problem is sorted, that even though it's able to execute something, it's not able to steal anything out of that. You can also upgrade to the library directly, which solves the issue. If it breaks changes, these are some good ways to stop JS execution here. I just recommend that you either patch to the latest version, whatever you want to, and else set these or use these, any of these, to basically make sure that JS is not executed on your web application or desktop application. Yeah, that's it for the video. Yeah, have fun, have a great week ahead. Thank you for watching. Do subscribe if you like the video. Thank you so much.